We're going to do a coding challenge called Convert to Decimal. The objective of this challenge is to create a function given the name to convert a list of percentages to their decimal equivalents. So the decimal values should be floats. Here is an example. This is a very common situation when working with data sets, especially pulled from a web source or scraped from the web. We always want to be doing some kind of analysis with the data that we've extracted, and we can't do anything with data in this format. So this data is created in such a way to be a meaningful and intuitive display, but we obviously can't do computations with strings that contain symbols. So we're going to have to take away the percent symbol from each of these strings in the list of numbers, and we're then going to have to convert them to floats. So let's start off with a function definition. And the argument in each of these cases is a list. So I will use LST as the parameter name as we usually do. Okay. Um, our output is supposed to be a list of floats. So we're going to go ahead and create an empty list. And then after we've converted the values to decimal form, we can add them to that list. So let's call it out, short for output. Okay, let's do, well, first of all, let's just run the function. We'll get a bunch of nones because we have no return statement. So then let's go ahead and create a for loop for I in LST. Let's print I to see what we have as a development step. Okay, so there they are. Okay, so what I'd like to suggest, there are actually a couple of tools we can use here to take away the percent symbol. One would be strip, which is a Python method you could take a look at on W3 Schools. That's a good resource. We could also use slicing. That's the method I'm going to go ahead and use. And remember, we can slice starting at the beginning of an element, and then we can go up to any point in that collection or object using indices. So if I slice from the beginning of a term, say 1, right, is a string. So the first element is 1. The last element is a percent. So I'm not going to use index 1 in this case because I have some other examples where there are more than 2 items in the string. So for example, 98.1 has an item at index 0, 1, 2, and 3, and 4. The percent symbol is at index 4. So I would use the -1 because that is going to always go up to the second to last item in the list and include that in the output. So let's just print. So this has effectively taken away the percent symbol, which is always the last item in each of those strings. So now that we've done this, we can add the items to the list. But first, I think I'm going to want to convert these to floats. Okay. So let's do something like this. Let's save what we have. We don't just want to print it. We can give it a variable name, whatever we want. We can call it X. Okay, so just keep in mind now X is going to represent each of the items because it's defined in the for loop. So it's representing each of the values, but let's just use Y now to make the those values into a float. So we can use the float um, function to coerce each of those. And I'm going to print Y because I want to make sure that I am in fact getting all of those values. It'll look more or less the same. Okay, so now these are floats. So this is good. Noticing one more thing we have to do. These are still in terms of percentages. They're on the scale of percentages. We want them to be decimal values, so we still have to divide by 100. Why don't we go ahead and do that? in this step in line 7. Okay, there we go. So we've converted all of these to decimal. We are not asked to round in this problem, so we don't need to do that. So next thing I'm gonna wanna do is append. So I'll do out.append, and I want this in the for loop so I can do this repeatedly with each of the items that have been converted. Okay, still getting nuns. So we'll use a return, and the output is what we want. Okay. So this function should meet all of the criteria. We are outputting a list of floats. We are taking away the percent symbol prior to doing that. And we're making sure we divide by 100 to get decimal values. Okay, looks good. Thanks.